Welcome to Night Cosmos. Tonight we invite you on a quiet journey through the remnants of stellar life, the white dwarfs. These are stars that have exhausted their fuel, collapsed under their own gravity, and now drift as glowing embers in the darkness. They no longer shine with the fury of nuclear fusion, but they haven't gone cold either. Instead, they remain suspended in silence, glowing faintly for billions of years. If you enjoy drifting into the mysteries of the universe, don't forget to subscribe and stay with us for more celestial dreams. Now, settle in, take a breath, and let the stars guide you. The story of white dwarfs begins not in death, but in transformation. When a star like our sun reaches the end of its life, it doesn't explode in a supernova. It gently releases its outer layers, forming a nebula, while its core contracts into something dense and enduring. That glowing core, no larger than Earth, is the white dwarf, and in its quiet light, we find the ghost of a once living star. White dwarfs are the quietest survivors of stellar evolution. Unlike massive stars that die violently, smaller stars like our sun choose a gentler farewell. As they run out of hydrogen, their cores shrink and heat up. The outer layers swell into a red giant, enormous and majestic before drifting off into space. What remains is the heart of the star, hot, dense, and no longer generating energy through fusion. This remaining is a white dwarf made mostly of carbon and oxygen, packed so tightly that a teaspoon of its material would weigh tons. Though the star's life has ended, its presence lingers. These stellar corpses glow with leftover heat, radiating soft light as they slowly cool over billions of years. They don't flicker or flare, they simply exist, like a final whisper from the cosmos. It is this silent persistence that makes white dwarfs so haunting and beautiful. Stars that refuse to disappear, even when their time has passed. White dwarfs are unimaginably dense. Despite their size, roughly comparable to Earth, they can contain mass close to that of our sun. This means gravity on a white dwarf is immense. If you were somehow able to stand on its surface, which of course you couldn't, the pull of gravity would be hundreds of thousands of times stronger than on Earth. You would be crushed instantly. But these are not places for humans. They are cosmic relics meant to be observed from afar. Their surfaces are often featureless, covered in hydrogen or helium, and shining faintly in white or blue tones. Some of them rotate rapidly, others drift in pairs, locked in quiet orbits with other stellar remnants. Occasionally, white dwarfs consume matter from nearby stars, flaring up in sudden brightness, only to fade again into dim stillness. In their silence, white dwarfs remind us that not all endings are violent. Some are slow, gentle, and enduring. They are the stars that linger when others are gone. Though white dwarfs seem quiet and still, their creation marks the end of a long and turbulent life. For billions of years, the star that birthed the white dwarf fought against gravity. It fused hydrogen into helium, shining brightly, warming planets and shaping the space around it. But no fuel lasts forever. As the core ran dry, the balance tipped. Gravity took over. The star's outer layers peeled away like petals, and the once mighty engine collapsed inward. What's left is the dense ember of that long journey, a white dwarf. These objects don't burn in the way young stars do. Instead, they cool slowly over trillions of years, radiating stored heat. Some are surrounded by glowing planetary nebulas, beautiful clouds of gas and dust ejected during the star's final breath. These nebulae eventually fade, but the white dwarf remains. Alone, silent, and small, these stellar ghosts teach us that even in death there is beauty, and even in silence, there is story. In the vast darkness of space, a white dwarf is easy to miss. Their faint light doesn't travel far, but with the right instruments, astronomers can find them scattered across the galaxy. 1 billion quiet stars, glowing softly in the dark. Some are alone. Others orbit with companion stars, locked in slow gravitational dances. These pairs can be dangerous. In close binary systems, a white dwarf may siphon material from its partner. As the mass builds up, it can trigger a nova, a sudden burst of brightness, or even a type Ia supernova, which obliterates the white dwarf entirely. But most white dwarfs live quietly, slowly cooling, their cores fading in temperature and light. Eventually, they become black dwarfs, cold, dark remnants that no longer shine, but the universe isn't old enough for any black dwarfs to exist yet. All the white dwarfs we see are still glowing in this light. We glimpse the long patience of the cosmos and the echo of stars that refuse to fade. White dwarfs are cosmic timekeepers. Their predictable cooling process allows scientists to estimate their ages with remarkable precision. When we study white dwarfs in ancient star clusters, we uncover timelines that stretch back to the earliest days of the galaxy. Some of these stellar remnants are over 10 billion years old, making them among the oldest objects in the universe. They are like fossils, but glowing. Because they no longer fuse elements, they don't change rapidly. They become colder, dimmer, and more still. In their unchanging state, they offer clarity, a stable reference point in the chaos of the cosmos. This is one reason astronomers cherish white dwarfs. By measuring their temperatures and light curves, we can chart the history of stars and even test theories about the fate of the universe. Each white dwarf is a quiet witness, holding stories of stellar birth and death, silently drifting through the galaxy like a glowing memory. The surface of a white dwarf is not what you might expect. Though it appears serene, the physics there are extreme. Temperatures can reach over 100,000 degrees Celsius when the white dwarf is young, though it cools over billions of years. Its crust is made of dense, degenerate matter, atoms so tightly packed they behave in strange quantum ways. This matter is supported not by heat or pressure, but by something called electron degeneracy pressure, a quantum effect that prevents the star from collapsing further. This delicate balance allows the white dwarf to remain stable for eons. Occasionally, their outer layers reveal traces of heavier elements, signs that asteroids or planets may have fallen into them. Yes, even in death, these stars can still destroy worlds, but mostly they remain undisturbed. They are cosmic sculptures, frozen in time, shaped by forces beyond comprehension. When we look at them, we're seeing nature's quiet masterpiece, a star paused between life and nothingness. Some white dwarfs exhibit magnetic fields millions of times stronger than Earth's. These magnetic fields twist and shape their surroundings, affecting any material that drifts too close. In the rare cases when they spin rapidly, these magnetic white dwarfs can emit pulses of radiation or interact with nearby matter in strange ways. We call them magnetic cataclysmic variables. The names are dramatic, but the reality is eerily calm. Their light flickers slowly, like a heartbeat in the void. Over time, they grow fainter, and their magnetic energy fades. What's left is a cooling shell of matter that no longer remembers the fires that once raged within. Yet even these fading stars are important. They tell us about the limits of physical law and about how the universe chooses to store its energy. White dwarfs may not shine like their former selves, but in their silence, they carry the echoes of stellar storms. And in that silence, we find something profound. White dwarfs don't just tell the story of stellar death, they also help us understand planetary systems. Around several of these ancient stars, astronomers have discovered rings of dust and debris. In some cases, these are the remnants of shattered planets or asteroids, pulled apart by the dwarf's gravity. These dusty halos act like cosmic autopsies, revealing the fates of solar systems long gone. In a few rare systems, we've even detected signs of rocky planets orbiting extremely close to white dwarfs, surviving in a precarious balance. One day, our own sun will become a white dwarf. When that happens, Earth will likely be swallowed or reduced to dust, but the white-hot core of the sun will persist, glowing softly for eternity. White dwarfs remind us that nothing in the universe truly lasts. Yet nothing completely disappears either. Everything changes form, matter drifts, light dims, but something always remains. And in that faint glow, there is memory, history, and the soft breath of cosmic time. Some white dwarfs exist in binary systems with other white dwarfs. Over time, gravitational radiation causes them to spiral closer and closer together. Eventually, they may collide and merge into a more massive object. If the result exceeds a critical mass, the Chandrasekhar limit, about 1.4 times the mass of the sun, the white dwarf can collapse into a neutron star, or explode as a Type A supernova. These events are rare and spectacular, used by astronomers to measure the expansion of the universe. But before that final moment, for billions of years, the two white dwarfs circle each other like dancers in the dark, exchanging nothing but gravity and time. In their orbits, we see balance. In their stillness, we see patience. Their final collision is the only burst of violence in an otherwise quiet existence. Most white dwarfs will never reach this fate. They will simply cool and fade away. But for those few that do, their ending is as grand as their silence was long. The fate of white dwarfs is tied to the fate of the universe. As time stretches on, stars will die, galaxies will dim, and even black holes will evaporate. But white dwarfs may remain, slowly cooling, slowly dimming for trillions upon trillions of years. Some theories suggest that in unimaginable stretches of time, white dwarfs could undergo rare quantum events, causing them to collapse into neutron stars or explode. These black dwarf supernovae would be the last fireworks of a dying cosmos. But this is speculation. Right now, all white dwarfs we see are still glowing. The universe simply isn't old enough for them to go dark. So when we look at a white dwarf, we're looking into the deep future. We're seeing the kind of object that might outlive every galaxy, every planet, even light itself. And in that idea, the idea that some things endure far longer than we can comprehend, there is something strangely comforting. The stars may fade, but they do not vanish. Some white dwarfs are part of systems called cataclysmic variables. In these setups, a white dwarf feeds on material from a companion star, often a red dwarf. As gas spirals in, it forms an accretion disk, heating up and glowing brightly. Eventually, pressure builds until it ignites in a sudden outburst, a nova. This is not the end for the white dwarf. It survives, and the process may repeat many times. The system flares, then quiets like a cosmic breath. These recurring novae are among the more dramatic sides of white dwarf life, but even here, the pattern is predictable, the energy controlled. It's a reminder that even the most peaceful objects in the universe have cycles of intensity. A white dwarf can slumber for centuries, then flare in moments, only to return to stillness again. It is the perfect balance between chaos and calm, between fire and silence. And in that rhythm, we find the deep, ancient pulse of the cosmos, measured not in seconds, but in centuries. White dwarfs come in various types, classified by the elements seen in their thin atmospheres. Most are composed of carbon and oxygen, wrapped in a thin layer of hydrogen or helium, but some have atmospheres that reveal traces of heavier elements like calcium, magnesium, or even iron. These are likely signs of external material, remnants of planetary bodies torn apart and accreted onto the surface. This cosmic pollution tells a deeper story. Around many white dwarfs, there were once planets, perhaps even entire systems like ours. And now, those worlds are gone, leaving behind only their signatures in the light of the dying star. In this way, white dwarfs are like time capsules. They contain evidence not just of a star's life, but of its planetary companions, its history. When astronomers study their light, they see echoes of entire solar systems compressed into a glow no brighter than a candle. And in that soft light, we find the scattered memories of a vanished world. In 2015, astronomers made an extraordinary discovery, a planet orbiting a white dwarf. The planet, called WD 1145 plus 17b, appears to be disintegrating as it circles its collapsed star. Its surface is being torn apart by tidal forces, leaving behind clouds of dust and gas. This dramatic scene confirms what scientists long suspected: planets can, at least briefly, survive the death of their stars. But survival comes at a cost. The planet is no longer whole. It is breaking apart, bit by bit, like a ghost of what it once was. White dwarfs are dangerous neighbors. Their intense gravity, radiation, and tidal effects make it hard for anything to last nearby. Yet the fact that anything remains at all is a testament to cosmic resilience. The universe doesn't erase everything in death. It leaves behind fragments, shadows, and clues. And around these faint stars, we see those clues illuminated. A glowing remnant of a star, and orbiting it, the remains of a planet trying to hold on. Not all white dwarfs are solitary or paired with other stars. Some exist in large groups, remnants of ancient star clusters. In these dense environments, white dwarfs drift among thousands of other stars, like embers scattered in a dying fire. These clusters, such as globular clusters, are among the oldest structures in the universe, and within them, white dwarfs are like tombstones marking stellar history. Their presence helps astronomers map the age and evolution of the cluster. Each white dwarf tells a chapter in the long story of a group of stars that formed together and aged together. In these ancient environments, the silence is deep, the light is faint, and the sense of cosmic time is overwhelming. Billions of years pass in stillness. The white dwarfs remain, slowly fading but never quite gone. In this quiet dance of stellar memory, the universe whispers its longest tales, and if we listen, we can hear the hum of time stretching endlessly outward. One of the most haunting things about white dwarfs is how little they change. For billions of years, their temperature decreases slowly, their light dims incrementally, but their structure remains. No great outbursts, no violent shifts. They are the ultimate instability. Matter crystallized under unimaginable pressure. In fact, some scientists believe that over time, the carbon and oxygen in the core of a white dwarf solidify into a massive cosmic diamond. Yes, a star that becomes a diamond. This is not poetic exaggeration, but a real possibility, supported by the physics of stellar cooling. One such star, BPM 37093, is nicknamed Lucy after the Beatles song Lucy in the Sky with Diamonds. It may be a crystallized core of pure carbon, shimmering invisibly in the darkness. These are not stars in the traditional sense anymore. They are sculptures of pressure and time. In the quiet chill of space, they remain, turning slowly into jewels of silence, waiting to be discovered. The journey from a blazing star to a quiet white dwarf is one of the most dramatic transitions in the cosmos. A star that once forged elements in its core, shined with nuclear fire, and held entire systems in orbit, ends as a dense, silent ember. And yet, in this stillness, there's dignity. The white dwarf carries the memory of its past in every atom. It's no longer creating elements, but it's also not gone. It exists in a new form, compact, stable, and enduring. Unlike the chaos of a supernova or the darkness of a black hole, the white dwarf remains visible, peaceful, and present. It's not flashy. It doesn't command attention, but in its quiet persistence, it tells the story of survival. Stars may die, but they do not vanish. They become something else. And that something, a glowing pearl in the sea of space, continues on long after the storms of life have passed. In its glow, we see the universe's gentlest farewell. There's something almost human in the fate of white dwarfs. They live brilliant, burning lives, full of energy and change before settling into a quiet, reflective phase. In their final form, they don't demand attention. They simply are, steady, enduring, constant. Much like the way people grow, shine, and eventually find peace in stillness, white dwarfs reflect a universal rhythm. They are not forgotten by the universe. In fact, they become its most reliable witnesses. As galaxies spin and stars rise and fall, the white dwarf simply remains. A fixed point, a reminder. In the grand chaos of existence, they offer calm. And perhaps that is why we're drawn to them. Not because they explode or dazzle, but because they endure. They are the cosmic echo of life lived and ended gracefully. The stars that never truly die, the embers of eternity. And in the silence of their light, we're reminded that peace, even in the universe, is a kind of power. Imagine floating beside a white dwarf in the vacuum of space. The light is faint but sharp, the surface smooth and glowing like polished ivory. There's no sound, no storms, no radiation bursts, just a constant, unwavering glow. Its gravity would crush anything nearby, but from a safe distance, it is serene. You are watching a star in its eternal rest. It does not ask for attention, it does not change, and yet you feel its story. The weight of time, the echoes of creation. You see in that dim light 1 billion years of existence compacted into a single glowing sphere. It is beautiful not because it shines brightly, but because it has lasted. It has endured all the violence of stellar life, and now it rests, holding the secrets of a universe that keeps moving. A white dwarf may not dazzle, but it speaks in its silence and its glow of time, memory, and the quiet majesty of survival beyond death. White dwarfs also challenge our understanding of physics. Their extreme densities offer a natural laboratory for testing theories about matter under intense pressure. Inside, atoms are packed so tightly that electrons are forced into higher energy states, creating what's known as degenerate matter. It's this electron degeneracy pressure that prevents the white dwarf from collapsing further. Without fusion, it's only this quantum effect that keeps the star stable. This is a place where the rules of everyday life break down. Gravity, time, and matter all behave differently. Studying these remnants helps physicists refine models of quantum mechanics and stellar evolution. So while they may seem like simple, quiet stars, white dwarfs are actually among the most complex objects in the cosmos. They push the limits of what we know and what we can calculate, and that's another reason they're so important. They don't just mark the end of stars, they open the door to deeper mysteries we're only beginning to understand. As we gaze deeper into the cosmos, finding more white dwarfs scattered among the stars, we're also gazing into our own distant future. Our sun will one day follow the same path. It will swell into a red giant, burn its final layers, and shrink into a white dwarf, a glowing pearl where once a brilliant star lived. Earth will be gone by then, scorched or consumed in that final expansion. But the sun's core will remain, drifting quietly through the galaxy, holding within it the memory of us, of this moment, of everything we were. Future civilizations, human or not, may find it and wonder about the world that once orbited it. They may study its light and learn of the system that gave birth to life. In that sense, white dwarfs are not just ends. They are monuments, cosmic gravestones that mark the passing of stars, and perhaps civilization. Their light is not loud, but it is eternal, and it waits patiently to be seen. Thank you for joining us on this journey through the ghostly glow of white dwarfs, the stars that never truly die. From their origins as brilliant suns to their final form as quiet, shining remnants. They remind us that even in silence, there is meaning. Even in stillness, there is strength. These stars don't scream their stories, they whisper them. And in those whispers, we hear the hum of the cosmos, the passing of time, and the endurance of life. If you enjoyed this exploration into the heart of stellar afterlives, be sure to subscribe to Night Cosmos, where space is not just distant and vast, but personal and eternal. Let your nights be filled with wonder and your dreams take flight among the stars. Until next time, look up, listen to the silence, and know that out there in the deep velvet of space, some stars still glow just for you. Sleep well, dream deeper, and good night from Night Cosmos.